Okay, so we're going to start off doing the Briscoe 8th grade math star review. So let's go ahead and start on the first topic. So we have our formula chart if we need it. We don't need it for this first topic, but our first topic is going to be numerical representations. So this was the first topic we learned at the beginning of the year. We have 4 takes that we talked about. 8.2a, I can identify subsets of the real number system. So that was here, the real number system. We'll talk about that in a second. 8.2c, convert between standard decimal notation and scientific notation. That was this topic right here. 8.2d, ordering a set of real numbers. That's this bottom one, ordering numbers. This one is bolded and has a star because this is our readiness take. You're going to see the most questions out of all these 4 topics on this one right here. And 8.2b, I can approximate the value of an irrational number and locate the rational number on a number line. So that's the square roots right here. So let's go ahead and start off with 8.2a. So we have our real number system. So the overall system of numbers that we've been talking about since y'all guys started learning about numbers is the real number system. We have 2 main categories, rational and irrational. Rational has a whole bunch of subcategories, smaller ways we can classify them, more specific ways to classify them, but irrational, when they're in this is the only way to classify them. So let's go ahead and do some examples of irrational. So irrational numbers are non-terminating, non-repeating decimals, or non-perfect squares. So these are going to be numbers like pi, because we know pi goes on forever and it has no specific pattern. That's non-terminating and it goes on forever, and non-repeating, there's no specific pattern where we can predict what the next number is. We just have to remember it. These are also non-perfect squares. Like, for example, remember, perfect squares are like the square root of 4, because 2 times 2 gives you 4, or the square root of 36, because 6 times 6 gives you 36. So, for example, the square root of 4 is a perfect square, but the square root of 5 would not be, because there is no specific number times itself that will give me 5. And we can check that by, let's see, many 1, 5, okay. The square root of 5, enter, it's not a perfect number. It's not a whole number that terminates. It's going to go on forever. Remember, your calculator rounds because it's not going to go on forever. Like, it only gives you 5 decimal places. But the square root of 5 is 1. Let's see, the square root of 36 is 1, so 1 less would be the square root of 35. So the square root of 36 would have been a perfect square, so we run under to get an imperfect square. And let's check that the square root of 35 is a random number, not a perfect square. So there's some examples of irrational. Now let's go ahead and look at some examples of rational. So rational are fractions, repeating decimals, and terminating decimals. So this is going to be in general, for example, negative 1/2 or even positive 1/2. It also says repeating decimals or terminating decimals, such as 0.2 or 0.2 repeating. It repeats, so since we know what the pattern is, it would classify as a rational number. We also have numbers like 15%. Anything with a percentage that's not going to change to a whole number will overall be rational. Because remember, 15% is just 0.15. Then we have integers. Integers are whole numbers and their opposite. So a whole number would, for example, be 2. Their opposite would be negative 2. So that would be an integer. A whole number is positive counting numbers starting with 0. So 0, 1, 2, going on forever. So 2, remember, whenever we're classifying it, 2 is a whole number, but it's also an integer, it's also a rational number, it's also a real number. So we're going out. Whatever number this is, it's going to go to all of these categories. Whatever number this is, it's going to go to all of the outside categories. You're going out. Because think about it, this box here, the integer box, is inside rational, so it has to be rational. This rational box is inside real, so it has to be real. Natural numbers are positive counting numbers starting with 0. So 0, 1, 2. So that's our real number system 8.2a. Now let's go ahead and talk about square roots. This is 8.2b. So let's just label it for our sake. So a square root of a number means that what number times itself will give you the number inside the square root. So for example, if we had the square root of 36, what number times itself would give me 36? Well, 6 times 6 would give me 36, so 6 is going to be the square root of 36. We estimate non-perfect squares by using a number line. So let's go ahead and look at this example. So we have 5. What number times itself, what number could I plug in here that times itself would be 5? So the square root of 25 would give me 5. 6 would be the square root of, just like our example said, 36. So we're just squaring it and then taking the square root of it to get back to 5. So I know that Q, this point right here, is going to fall between the square root of 25 and the square root of 36. So which value is best represented by point Q? 5.4, that's on the left side of the square root of 25. So I know that this one's not going to be right. Let's see, this one could be it. It's between 25 and 36. 35.5, again, between the square root of 25 and the square root of 36. But the square root of 5.9 wouldn't work. And let's just check that, because if we typed in the square root of 5.4, let's see if it would fall somewhere between 5 and 6. I don't think it will, because if it would, it should be between the square root of 25 and 36. That's right, 2.23, that's somewhere over here on this side. So these two don't work. But now that we have it down to these two, let's go ahead and check the square root of 29.5. 5.4, and then the square root of 35.5, 5.9. Oh, I'm sorry, when I round, that would actually round up to, let's round to 2 decimal places, 5.96 and 5.43. There we go. So Q looks closer to be 5.43 than 5.96, so B has to be the answer. Sydney completely covered a square wall using 87.5 feet squared of a wallpaper without any overlap. What is the measurement of the side length of the wall in feet? So whenever they give us an area and we're trying to find the side length of a square, then we can use our square root. So the square root of the area would be your side length. So here the area is 87.5. So we just plugged in the area. The square root of that area, 87.5, would give me the side length. So let's go ahead and type that into our calculator. Remember, control this x squared button. You see your square root in yellow right there? We'll pull up our square root symbol. So 87.5. Click enter, 9.35414. So let's round it to 2 decimal places to the hundredths place, 9.35, because the 4 keeps it the same. So we have 9.35. Our unit is feet. Now let's do scientific notation. Okay. So scientific notation is going to be 8.2c. Let's write that, 8.2c, just so that way we know. A value written as the product of a number between 1 and 10 and the power of 10. So it's going to be between 1 and 10, greater than or equal to 1 but smaller than 10. 8.52 is greater than or equal to 1 but smaller than 10, and to the power of 10, so 10 to the 6th power. So because it's positive, we know that we're going to be moving the decimal in the right direction. So it's right here right now. It's going to be somewhere in the right direction, and we're going to fill it up so we have 6 digits between this decimal and this one. So we already have 2 digits. We will need to fill it up with 1, 2, 3, 4 more zeros in order to get a total of 6 digits between our decimals. So 8, 5, 2. I said we're going to need 4 zeros here. 1, 2, 3, 4. So here's my decimal now. My decimal was right here between the 8 and the 5, and I should have 6 digits to make sure that I did it right. 1, 2, 3, 4, 5, 6. So yes, I did convert this correctly. I can do some of them on the calculator, not all of them, because the calculator doesn't do an unlimited amount of digits. But let's see, 8.52 times 10 to the, remember our 5th power is right here, or you could use this 10 to the x power button, to the 5th power. 852,000. Oh, I'm sorry, that should be to the 6th power. To the 6th power. And so see, this one didn't work. So it only works to a specific amount. Sometimes if it's too long, it'll just say to the 6th power, which we already knew. Remember to check if the exponent is positive or negative, right? Remember, if it's positive, it's gonna be a really big number, such as the distance from the Earth to the Moon. But if it's negative, it's gonna be a really tiny number, like how big a little piece of salt is. So it's gonna be really tiny. So scientific to standard, 4.235 times 10 to the 7th power. So this is a positive exponent. I know it's gonna be bigger. My decimal's here right now. I know it's gonna be somewhere to the right. And I'm gonna need 7 digits between where the decimal is and where it's going to be. So I already have 3 already, so I know I'm gonna need to add 4 zeros in order to get to 7. So 4, 2, 3, 5, and then 4 zeros, 1, 2, 3, 4. And now my decimal's here at the end. But we don't need to write that decimal because it's always there, it's just invisible. So let's check. It was between the 4 and the 2. So we have 1, 2, 3, 4, 5, 6, 7 digits. I know I translated that correctly. 6.88, this time since the exponent's negative, it's gonna be going somewhere to the left. I know between here where my decimal is and where it's going to be, I need 7 digits. So right now I only have 1, which means I'm gonna fill it up with 6 zeros in order to reach that 7. So let's put our decimal, 6 zeros, 1, 2, 3, 4, 5, 6, and then the numbers that we have, 688. So it was here between the 6 and the 8, and now it's right here. Let's count. 1, 2, 3, 4, 5, 6, 7. So I do have 7 digits between where it was and where it is right now. Standard to scientific, remember we're gonna move our decimal right now. When it's a whole number, it's right here at the end, but I'm going to move it so it is somewhere that in between a number that gives me a number bigger than 1, greater than or equal to 1, but smaller than 10. So if I were to move it, for example, right here, 129 is not smaller than 10, so I don't need to move it again. 12.9 is not smaller than 10. 1.29 is smaller than 10 and still bigger than 1. So we're gonna move it right here. So 1.292. I don't need to write the extra zeros, I just need to write the actual numbers that we have right here. If they're the zeros at the end, I can leave them off. So times 10 to the, this was originally a big number, so I know it's gonna be positive. So it was right here. I have 1, 2, 3, 4, 5 numbers between where it was and where it's at now. So to the 5th power. So right now my decimal's right here. I'm gonna move it between the 9 and the 7. 9.7 is greater than or equal to 1 and still smaller than 10. So 9.7 times 10 to the, it was originally a small number, 0.00097 is really small. So it's gonna be negative. And then let's count how many digits between where it was and where it's at now. 1, 2, 3, 4, 5 digits. So it's to the negative 5th power. And now let's do our readiness TEK 8.2D. 8.2D. We're going to see the most questions out of these 4 topics on the STAR on this one. So we have to put the numbers in the same form first. I always recommend putting them in decimals because that's going to be the easiest way to translate. Remember, Control Enter will always give you a decimal in your calculator. For example, convert numbers to decimals before ordering. We just talked about that. So we have least to greatest. Whenever it's going to be doing that order, it's going to be words such as increasing or decreasing. If it's greatest to least, it's going to be words such as decreasing or descending. I'm sorry, increasing or ascending. And greatest to least will be decreasing or descending. Example 1, order the numbers from greatest to least. Now, we're going to also remember a trick. If it's least to greatest, least is the first word. So it's going to be less than first. So less than. We're going to make an L with our fingers and then close it, and we have our less than symbol. We can also make a lowercase g with the other hand. So this is going to be greater than. And if I make that symbol there, it's going to be facing this direction. Or you can just remember less than is this one, and the greater than has to be the opposite way. So we're going to use this for our calculator to check our work later. But let's go ahead and order them from greatest to least. So we got to convert all of these into decimals. So luckily we have our calculator. NU15 if you want to clear it out. So 9 pi. Click enter. And we get 28.27. So I'm going to write this here, right under it. The square root of 3, control divide will pull up our fraction, over 2. And control enter gives us our decimal, 0.87. So 0.87. And then 27.5 is already a decimal, so that's just 27.5. We want it from greatest to least, so we want the biggest number first. So that would be 28.27, but we want it in our original form, so that was 9 pi. So 9 pi, comma. So that took care of that one. Now, out of the 2 we have left, we have 27.5 is going to be bigger. That was originally 27.5. And then the smallest one, cross that one out too, 0.87, which was originally the square root of 3 over 2. Now we want to change it to its original form because that's how our answer choices are going to look like on the STAR test. Now going back to checking our answer with the calculator, greatest to least. So greatest is first. We're going to use our greater than symbol in order to check our work, which is facing this direction right here. So I'm going to write the number that I think goes first, the greatest one, 9 pi. And then control equal will let me pick the symbols. I want the greater than symbol. This is my G, so this is greater than. We're going to type that one in next. Then my next number, 27.5. And then our greater than symbol again, control equals greater than. And then the last one, the square root of 3 over 2. And if I ordered them correctly, it should say true. If I had messed up in my ordering, it would have said false. So this is true, so I know that this one is ordered correctly. So now y'all guys are going to go ahead and do your numerical representations practice. So that way you can practice the topics that we just did together right now. When you're done, make sure you do the quizzes.